This pops on a very cold morning out there. We have frost, and it said 37 degrees on the National Weather Service, the feds. It's a lot colder here in the valley when there's almost no wind. When you're down to about 5 miles an hour and below, we're colder than they are at the airport, 1,600 and some feet up on the hill. Our level here above sea level is 880, 890, just under 900 feet. Then you go to another site and it says it's 900 and something, 905 or whatever. But yeah, the river's, I'm going to guesstimate 150 feet or so below us. Susquehanna, that is, where we are. I got this, and I'm not sure. It has something on here about a little notch and pull this and turn that, and I don't know. I guess it's some type of lock in there that I didn't know about when I bought it. We shall see. What am I on here for today? Well, last night I went through the Roosa Master injection pump and what I knew about that. Just to kind of, well, the main reason is I haven't gotten into any of these pumps. I let the diesel guys have it over the years. But the stuff I run into externally, that's a different animal. A BOSCH pump, that has some of its own little quirks, but it's not a lot different than the Roosa as far as general operation. However, where the Roosa has 2 or 4 high-pressure pumps, pistons pumping, they'll have a DB2 or a DB4, 2 and 4, for more fuel volume. The BOSCH pretty much changes the depth of its little piston. It has 1. Now we're talking about the not the VP44. We're talking about, I believe they call it the VE pump. It's a distributor pump, and it's obvious from the outside it's a distributor pump. Setup is somewhat similar to the Roosa Master and to the, what do they call theirs now? It used to be Minimec, then it was CAV Lucas. CAV Lucas, I think. They had another name in there too, I can't remember. But anyway, there's a lot of similarities between the three. You can't change a distributor pump a lot. On the BOSCH pump, now where they have a timing mark on the stanadyne delphi pump, they do not have a timing mark on the BOSCH. They do not. Don't let anybody tell you any different. Now, they'll have different cam rings for 4 or 6 cylinder, probably even 3. They all do, obviously. On the BOSCH, however, the cam ring runs a piston back and forth. So as the cam ring turns, it moves the piston with each bump, and then as it turns, it lines up with the distributor hole to distribute. The BOSCH is known for being a little better at high pressure than the Roosa. The Roosa's end head, the one that looks almost like a daisy and has the adapters coming straight out, not straight out of the end, but flared out of the end and the row around it. That's a higher pressure pump. But the rest of it's doesn't hold up that much longer. It's similar. And the BOSCH is known for being a little higher pressure for 4, 5, 6,000 psi. It's not good for it, but it handles. Once you start breaking 2,500 psi, things start changing as far as stress and pressure on these systems fast. So, just to give you an idea, the common rail systems now, quite often, the low end of a common rail is usually around 5,000. Every once in a while you hear one that goes all the way down to 3,500, but most of the construction stuff and tractors I've run into, they idle as 5,000. Then they go up from there. Well, they need the pressure to get that much fuel in there because you're not pumping the fuel directly in there in many cases. It's stored, so you have to have enough pressure to actually take that accumulator and work it. Where a distributor pump, it's set. That little piston's moving, period. And the only thing they usually have is a form of a sleeve with a groove in it, so when the piston pumps, that it reaches a certain point on that sleeve where it just goes to tank. It stops pumping. That's it. And it may go to the inside body, it may go to the return side, depending on how they set the things up in all these pumps. But it's the same idea as the big inline pumps, but it's internal. And in the Bosch, it's just one and a cam ring set up for however many pistons there are, with an exact number of degrees between each cylinder, obviously. So similar to a distributor on your old car or tractor, they have to set that up in a sense. Dwell is factory set. You're timing number one cylinder. Everything else is mechanically taken care of. Now, they do have some control in this pump, from what I understand, but not as much as you would think. There's a timer. Well, it's a similar idea to your the thermal setup to the stanadyne delphi pump, where they'll have a solenoid in the timing side. It has to reach a certain temperature before it'll allow it to go back on normal timing. They wanted advanced time to get rid of the smoke while it's cold, so I have longer burn time. And then when it goes into normal running, depending on the company, they do it different. I know with Cummins, they had it would fire up, I think, on advanced time to keep it from smoking. And then once it got going and you were under a load, it snapped back to normal time, because it's under a load, and under a heavy load it'd have enough turbo heat. It's a lot of things that they were changing on there. Under a light load, everything advances timing. Everything. Because they want a longer burn time to keep it clean. I mean, even gas engines, under a light load, more timing. You start lugging, the timing comes back slowly, so you aren't pinging and knocking. They want a certain amount of pressure in the cylinders. Well, it's similar with a diesel. So there'll be some electronic and thermal on that, but the shut-off solenoid's right there on top of the distributor head, easily and exposed. It's not like the Delphi stanadyne that's underneath the cap internal, which is, from what I understand, still serviceable. I don't think I ever had to change one, and if I did, it was almost 40 years ago. A long time ago on an Alice 6000 series, if I ever did. Most of them are just bad connections. Same thing with the Bosch. The BOSCH VE pump. Same idea with that. It's a little bitty electric solenoid, and they go bad now and then, but the problem of it is the solenoid's like $400. So you're replacing that, and then, okay, it doesn't work. Now you got to put a pump on. Well, now it's $400 on top of what, $4,000? You know, it doesn't seem like much, but still, now it's $4,400 the bill instead of $4,000. I know it's not a trade-off on our end, but it is on the customer's end. You know, it's a gamble. We do this and did it. Yeah, okay. Now, before you go messing with a Bosch pump, I had mentioned it with a Delphi, this one, and definitely. Most of these pumps do not have a keyed gear up front. They do not. Sounds weird, doesn't it? Your Delphi stanadyne pumps may or may not. Depends on their mood. You have to know the torque. Don't just say, that's close enough. You have to know the torque. Well, in this Bosch pump, I can't remember what it was. And it's similar to the Delphi pump. But with the Bosch pump, what you have is near the mounting pad. This is the mounting pad. We'll put the pump out here. On one side of the pump will be a boss, like my finger. There'll be a hex here. All right. Now you've turned the engine over. You've lined up your your timing marks on the flywheel or on the front pulley, but almost all of them are on the flywheel. Why? The flywheel is larger. It moves more. You have more surface area for degrees. So when you line up that little mark and you're off a little bit here, it's less of a problem on the crankshaft and gears and everything else down here, but it's more precise because it is big. Okay, there's more area. The smaller you are and you move it, well, if you move it 10 thousandths here, out here it's a lot more than 10. So if you're up here this big and you move it 10, it's not that big a problem down here. So get your timing on your flywheel. A lot of them have a pin. This is where it gets goofy though. Where that little hex head is, there's a steel plate under it. Once you get that thing in the position where the timing marks are, Don't do anything else anywhere. You'll snug that bolt and you'll loosen the bolt, take the plate out, and move it to the open slot and turn the bolt in until it touches the shaft. Now don't fully tighten it down yet. Okay? Why? You've touched the shaft, it'll semi-help hold it, but you don't want to bind it unless instructions say so. Now you want to hold the flywheel where it is and loosen your nut on the gear. Unless yours is designed to take everything out. Almost all of these you take the gear off. You loosen your nut at this point. Your gear is not loosened up yet. And if it has, you've got a real problem. But at least you've got your bolt here finger or just a little more than finger tight. Once your nut is loosened up and you don't have to torque and twist it anymore, and you've held your flywheel or your gears up here, whichever, you've got the nut loose, now take that bolt and torque it down as they want it to hold the shaft in its position, because that's your timing. Now, why am I telling you to do this? Because it doesn't matter, the pump company's going to take care of it, right? Yeah, but you have it on top dead center by the marks here. You have it on top dead center and confirmed with either compression stroke or the valve, not just piston location, because piston location on whatever is number 1 can be at top dead center 180 off. I should say 360 off. It can be on the compression stroke or the exhaust stroke on a 4-cycle. So you have confirmed that your valves are loose, or you've brought it up your front pulley clockwise rotation until you're knowing on compression stroke. Bring it to the top and line up your marks. Well, in some cases it might be you line up timing marks. Whichever it is, you follow your book. Now you've got it set, you've got your nut loose, torque that lock bolt down. If they don't have a torque, make sure it's good and snug. That holds the shaft in the timing position. And this is just practice for you. Because if all of a sudden somebody decides they don't want to do anything with that pump, you're locked in the original timing position, and at least it won't run any different than it did before. Or it shouldn't, unless something else went wrong, which can happen. Been there, done that. Tear it apart, put it back together, and why doesn't it run the same now? Because I tore it apart and put it back together. Parts fell out, stuff's gone, it was busted, you know. So now you've got your shaft held in position. Now most of this, if everything's going right, you're changing the pump out. You got a bad pump, you know it's a bad pump, you've done your tests. This is just plain practice for you. Later on, if you're troubleshooting now it gets different. You've locked it in the place that it was. If you're doing further troubleshooting, now you can put your little dial indicator in the end. These pumps have a dial indicator. Take the end plug out on the distributor head, put your dial indicator adapter in there, zero it as it is, mark the shaft before you move anything. And if you can, put a nut and a couple of washers and a pointer on there, say out of a piece of coat hanger or something, or even control wire off a lawnmower, something relatively substantial. Mark your position so you know where you're going back originally. Don't move it any more than 90, like a 180 total swing. But what you're doing is you've got the dial indicator at the moment of timing when the injection's supposed to begin. What are you doing now? Now you've got 2 markers on it. You go to loosen the thing up, and now you can rotate your shaft, and you know how far you don't want to rotate it. But you can watch your dial indicator to see your stroke length. You know where it started, it's 0. You turn it this way, it goes down. You turn it the other way, it starts going up. Now you can get your stroke length. That's how they set their timing on these things. And you've got your number 1 mark here, confirmed on your cylinder and confirmed on your timing marks. You're going back through your troubleshooting and you're watching your stroke length for number 1. That's how you set your timing when the pump shaft is loose. The hard part for you, if you screw up, which one is number 1? The book may tell you. How are you going to confirm it? Sometimes the book will tell you where the key slot is in position for number 1, because it turns at camshaft speed, half of crankshaft. So that's 1, 2, 3, 4. It's going to follow the firing order all the way around. 2 engine revolutions to 1 cam and then pump revolution. So you will be able to set your timing yourself with a dial indicator on the end. It's a relatively inexpensive tool. I bought one for when I was at J.P. Riley Construction. I had the company buy one so that we could set some of the pumps there. It turned out to be crucial. But if you set all your marks and everything beforehand, and now you're going to go through troubleshooting before you start sending the pumps out for $2, $3, $4, and $5,000, because this one you can, then you can go backwards. Now you know where everything is. You know where the engine's set. You know where the shaft is set. You know where your lock bolt is set. You know where your dial indicator is and what you're starting at. So all of your positions, if it was a running engine before, now you've confirmed number 1 3 ways. Number 1, compression, flywheel, valves and compression, and the position on the pump. And all these things are critical. Even before you pull a gear off, you can take the nut off and make a mark between the gear and the shaft, because the gear is going to stay there. In some cases, the gear can come out, but in most of them, it can't. It stays right there, very little clearance. And if it does, then mark the shaft, mark the gear to the housing. And you'll have all kinds of places and ways to realign everything when it goes back together. Or while you're troubleshooting, you can set your pump up. That is all practice. Now, if you're one of those that doesn't care, you take your pump off, toss it to them, have they redo it. Now you set your engine to top dead center and confirm it with compression and the valves and the flywheel. And now you just put your pump in, assemble it, and go. Sounds easy, doesn't it? However, when you're going back together, you're putting your pump in, and you leave that bolt alone. And you make sure you're either pinned in the flywheel or somebody's lock the flywheel in position. And now you're turning the nut up and hand snugging the nut. Once that is snugged up, make sure that even in that case, while you're snugging things down, you're lining up your marks. Put some marks on there. Tighten the nut down. By hand, good and firm. Your taper's clean, your gear is clean. The only thing you ever put on either of those, never put motor oil or anything even close. No grease, nothing. You either put it together naked or, as I've done in years past, WD-40, a very light oil. So, well, that's just a light oil. The 2 problems. A good, solid, common oil that you'd have today, the synthetic, that leaves a film in there. And they've actually had gears and some other studies and tests loosen up. And you're saying, well, you can't. Well, Cummins used to say dry, but they were 150 foot-pounds, give or take, 140 to 165 to torque the nut in some of those on the big pumps. So down here with this one, I can't remember what it was, 65, 95, something like that. So it is important that it fits properly. Just a little squirt of very, very light oil. WD-40 is what I recommend. Keep it clean. You got blaster, use that. Do not use spray grease. You want something that, as it presses on, lubes it, and then it goes out of the way. Torque it, and when you're done, your minimum torque, because they usually give you 2 steps, like 10, 15 foot-pounds to start. Loosen up your bolt, timing bolt on the side, this guy. Loosen it up, put the steel plate under the bolt so it does not go all the way back in again, and torque it and snug it. And if you want to be a purist about it, put a little blue Loctite on it. Excuse me. Now finish tightening your nut. You're golden. You can with your dial indicator, and I did it on one engine because I gave the guy the wrong position on the flywheel. Sorry, Caleb. We were working on a what did they call it? Iveco, which was a 3-cylinder Ford. Was it? No, it was a 3-cylinder Cummins. Iveco had the license to build the engine. It was a 3-cylinder Cummins, something Cummins never built, but it was a B-series 3-cylinder. And I gave him the wrong timing pin location. One I'd never worked on before. There's no timing pin hole in this flywheel. It's a long diagonal slot in the flywheel. It's huge. Works good if you know what you're looking for. And we were able to go backwards through that and confirm, number one, in multiple ways. One of them was we had the fuel system primed, we had the flywheel, we had the position, we had all of it, and turned the engine over. And when it came up on number one, and then we were able to check the dial indicator. So when we got done with that thing, it was premium. Now, what are some of the things that go wrong with this pump? Well, the same with any distributor pump. If your return line, just like I mentioned the valve on the stanadyne, delphi, roosa master, the return valve is a problem. Well, the return can be a problem on these. I can't remember if this system has a return valve because they don't have the same problems with these that others do. One major problem this pump system has, major, I mean, did I say major? Major problem. It's not all the time, but when it happens, it's aggravating. If somebody runs these things out of fuel, or you fire the thing up, you have to hand bleed this entire primary system all the way to the pump. And then crack an injector, crank it over, tighten it. Crack another, crank it over, tighten it. You have to critically bleed the pump body, everything. One thing this pump hates more than anything else is to run out of fuel while it's running, period. When it does, leave it alone, walk away, unless it's in the dead of winter. Then you can go get your fuel, put fuel in it, bleed your system, and if it cools down enough, it'll restart. But they get airlocked. I had one they couldn't get started. I couldn't get it started, and then after it was hot weather, and after a few hours, all of a sudden the thing just fired up and never had another problem with it again. And I got talking with guys, and they said all of them are like that on this system, and that was a 1004 Perkins, which love these pumps. So that's something else to keep in mind with these. That's one of the biggest headaches they have. Now, some guys are going to tell you they've cracked all the injection lines, cranked her over, and it worked fine. So have I. I'm just saying start one at a time. It helps. Now, in this pump, doesn't seem to be as critical as the stanadyne or the CAV pump. But, CAV Lucas, I should say. But it does appear that occasionally you just crack one line at a time. The solenoid itself isn't so much a problem, but transfer pumps. Now, here's a pet peeve I'm going to have with all of these. It's just, when you replace this pump, even though they all have their own little pump inside, transfer and pressurizer pump, that's to pressurize the pump body. That's to pressurize your advanced system. That's to keep it cool and lubricated. Okay, and to charge it. It's not to fight your problems before it. So almost all of these have some form of a transfer pump, unless they have an excellent gravity feed coming from a tank. They will have a little pump on the side here, a little electric pump or something just to get fuel there at a consistent rate. It's important that when you replace this pump, never replace it without filters, checking your lines, checking your tank screens, and between the tank and the delivery pump, your transfer pump, make sure it's wide open. Any screen is gone, cleaned. The fuel shutoff is opened up and cleaned, all of that. And the other one is, when you're done with all of this, you've got all that nice new line, nice new filters, everything in there, check your fuel pressure. And always, 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 you can check it by hand. That'll give you an idea. Make sure you got fuel spurting out of the diaphragm mechanical ones. And then deadhead it with a gauge. Yeah. Fill the gauge hose completely full of fuel. Squirt it up. Plug your gauge in. You're just talking a little bitty, one of those old-fashioned pressure vacuum gauges. That's all you need on most of these. It goes to 15 psi. Well, if you're careful. Most of these little pumps don't go over 15, but just start pumping the thing and slowly release it. And watch it go up. It's spring. There's spring applied. It's mechanical suction and then spring applied so that when you get to the set pressure, it just stops. So you say, I want a bigger gauge. Get a bigger gauge. I don't care. So these systems are pretty simple. They just need fuel delivered to them, and then they'll take care of themselves. But they do not draw up well or for very long. It wears the vanes out. And when the vanes are worn, it won't draw it very well anyway, and I've done it on 3 or 4 tractors in the past. You put a little fuel transfer pump under 10 psi, keep it down around 4, 5, 6 or less. 0 to 3 quite often works for these. You just want to get the fuel to it. And when it's there and it doesn't have to fight, there was one guy that had a 70-40. He says, it runs perfect, but I just don't have a lot of power. Yeah, because it couldn't deliver enough fuel. It was just working so hard to draw, it didn't draw well. Smooth as silk, but it couldn't fill the pistons well. And as soon as we put that little transfer pump on there and shot some fuel in there, he said that thing came alive and it made a 70-40. It was rated about 140 horsepower, someplace in that range, 130, somewhere in there. And he says as soon as you put that on there, it took a 1066 International that had been dynoed at over 160 horsepower. And he says that's dynoed, rating at 160 horsepower. So I had more. He said, ate it alive. The tractor had 4,000 hours on it or something. He says, ate that 1066 alive. That's how much of a difference it makes. Because 70-40 are saddle tanks. Well, if it doesn't have to draw, the fuel's fed to it. That little pump went wild. And so did that engine. Now you say, well, yeah, but now you're overworking your engine. No, you're not. Your engine's running the way it wants to. And your pump's running the way it wants to. Why? Because your regulator and your fuel pump internal are in full control of what's happening after that. Well, you're supercharging it up there. Yeah, maybe so. It has a regulator. It'll take care of itself. And you will be a happy camper. But that's a worn pump. Just a warning for the future. Okay, that's a worn pump. What's going to happen? Well, pieces of that little pump going to go through there and eventually end up in that return port on a CAV. Even on a BOSCH, metal pieces or whatever can go through the return. You've got to be sure your return line and everything else is clear and your tank vent is clear. Why? It's rare, but I've had it happen once or twice. Tank vent went bad, tank pressurized the return, couldn't empty the body, shut the governor off, tractor couldn't run. Tractor couldn't run. Don't tell me your stories otherwise. Tractor couldn't run. It's only been 1 or 2 cases in the last 40-some years, but it has happened. Very rare. In fact, I had an over-the-road truck do something even weirder. It went down the highway with 1 fuel tank, not 2, just a dump truck, and because the vent failed in the tank, no, it was 2. It wasn't 1, it was 2. It was the federal DOT, no crossover, so there's Y pipes down to the tanks. And what had happened was one on one side got more heat than the other. It did. It pushed all the fuel out of one side into the other because the vent didn't work properly. And then when it got down low enough, because the fuel's over here, it had enough pressure in this tank that it actually pushed air into the system and stopped the truck dead. Don't tell me it didn't happen. I was the one that took the cap off and it blew it in my hand. I didn't watch somebody else do it. I did it. And the vent in the tank failed. And it pressurized enough to push all the fuel over to the other side and run the vaporized fuel that can't burn up through there just like air. True story. I saw it, diagnosed, and did it myself. You can take whatever you want from that. Next off, I'm going to cover a couple other pumps. But while we're here, VP44 BOSCH, some of you are probably wondering a little bit about that. I've never done a lot with that, but I have done some in the past, changed probably half a dozen of them or more between Cummins Northeast and down here at the Burr truck. Talk about squirrel world. I hope they've done better than they did when I started there years ago. VP44 is often fed with a transfer pump that delivers, I think, 35 to 55 psi. Like 40 to 45 is what it wants, and it's in a fuel filter housing, a little electric pump on top, and that feeds the VP44, so it doesn't have to be fed otherwise. VP44 has its own controller on the pump, which in some cases causes trouble, and they found out that there are no failures in the VP44 pump years ago now. Might be a difference now. But there were 9,000 codes. They were specifically designed in the Cummins system to come from the VP44 into the Cummins system to tell it that the pump personally, by itself, had a problem. Now, we are talking a distributor pump, and why I'm talking about it here is the VP44 is based on the VE44, and then you'll say it's a totally different animal. It is, but the basics and the design of it are similar. Take the governor housing off and put a controller on there. It handles everything in here. It may take the information from the sensors in the Cummins, and the Cummins works the software program to work with it. But it is its own banana with its own big old connector on there. And when they're working right, oh, slick. Man, they took those 6.7 Dodges, or Cummins engines and 5.9s. Oh, man. Smooth start. Beautiful. However, they had the same problem as the VE pump. There were some of them that you changed the pumps and it would not bleed. And it would not pressurize. You couldn't get it to. One guy told me at Cummins it was so bad one time they disconnected the intake heater and ran ether through it to get it running. I had to do that on one. It was bad. It would not. It would bleed out to the injectors and still never develop pressure. Give it some ether, get it spinning so it could work the air out of there. Off it went. I had guys screaming at me. Hey, what do you want me to do? It won't fire. You don't know what you're doing. Yeah, I do know what I'm doing. This ain't working. So when I got done, everything worked fine. Truck went off on its own way. So this one also, I don't remember how I positioned the pump, but I knew the pump came through, and I'm almost thinking it was a keyed pump, but I can't remember specifically. I got a feeling it had a lock bolt, but I'm thinking it had a key. And still, you set your top dead center so that you can get the key in there. It's just, you've got to have it set. And similarities there. The VE pump, get air in it and hot, won't start. The VP44, sometimes you change your filters. Most of the time you're not going to have a problem, but every once in a while that would go bad. Well, how could that do that? I'll tell you how. One of the ways it caused trouble is your filters are huge and they're thick and deep and they hold air in them, tremendous air. You fire it up and you're driving it around the yard. You let the thing sit there and idle for 15, 20 minutes. Great. Next morning you come in, won't fire. Because the fuel went around the air. It had enough to run. The only way to actually be sure it's clear is take it down the highway. Run that thing through the gears hard. Turn around and come back. You'll get a few bucks and snorts and burps, and then everything will be okay. But you can't just let it sit there and idle. Now the VE, like I said, that has a fairly good size one too, and that caused all kinds of trouble trying to get that sucker bled the same way. Would not develop pressure until everything cooled down, set, and then you tried it again to rebleed, then it would fire. Once fired, both of them are fine. But that is a pain between both of those pumps. Horrendous pain. I never ran into it. Good. Glad you haven't. I never ran into it. 1.5, 2 years at Cummins Northeast. Ever. Everything went fine. Then I got down here and that one pump would not bleed out. One before had a bad transfer pump. Got bad fuel in it. And the check valve locked, actually was glued to the side of the housing. A fuel oil company had bad fuel. And it would drain, as soon as you shut it off, it drained right back to the tank. Don't ask me why or how, but it would drain back to the tank. So I replaced the pump, charged the system, fired it up, ran beautiful. Snorted for a while, but it ran great. So stuff happens with all of these. Some of it is they sit in stock for so long that the preservatives that they put in the pumps and the calibration fluid for some reason will set up. You don't know why. It could be a little piece of debris or something that got in there from running and it hung up. You never know why. The governor sleeve doesn't move like it should. Get it spun, get it going. Everything's working. Yes, it's electronic on the VP44, the governor control. Completely electronic. But still, it seems to have a similar problem to the VE pump. Well, there's something else just for you folks to know. I heard complaints about both pumps. The main ones I've heard are just those. When they fail, the VP44 will send you a code that it failed. And the only other failure that occasionally would be a problem was it couldn't develop pressure because it's worn out. Well, then you have to read that in the monitor in your diagnostics. It'll probably throw you a code for low pressure, low input pressure. Now the the VE pump, V2, V5, I think it's similar to the other one where they give it the names for it, but the VE pump mechanical. What am I thinking there? That one's not going to throw you codes, but that when they wear out, they don't develop the pressure they should. Same idea. And I think both of these have to have, the VP44 in particular has to have that high pressure pump feeding it. And I think the VE pump just has something that delivers fuel to it. In fact, yes, it does. There's a very similar diaphragm pump to it that only needs 5 to 15 psi, just anything to get the fuel to it, and it's okay. The VP44, for some other reason, they wanted that to be essentially turbocharged. So, all right, supercharged. It's electric. Well, that's it for today. I'm going to have to hang this up because I guarantee you I'm probably, 29% in the battery, and it's after 9 a.m. 9:20 here on November 11th, the year of our Lord, 2023. I'm sorry. If you're Steve Bannon, it's, let me look at that again. What was it? It's 11 November, the year of our Lord, 2023. Hope you learned something from this, and remember, stuff happens. What I'm going to ask you to do is, you got a problem. This video isn't going to directly help you with the problem. It's going to give you ideas. That's why I don't have pumps. I don't take pictures. Even if I could, I'm not going to get that involved in it. Why? Because you have your pump, your filter. And if you don't have the owner's manual, the first step in troubleshooting, know the system. And the system is the individual task that you're looking at. And if you're in the troubleshooting side, then everything I've given you here can give you an idea how to follow through on the troubleshooting. But the first step is know the system. The second is understand and know the customer's actual complaint. And I mean the whole complaint. Everything. Ask them about, in this case, we're asking about smoke color, cranking speed, battery condition. How long has this been going on? You're asking all the questions. Has it been skipping? Has it been sputtering? Has it just shut off? Has it thrown beeper, the dash beeping, anything? You say, well, the VE, no, the VE doesn't, but the dash is often electronic with these things. And has it been running funny? How about the fuel that you've had in it? What time of year is it? What kind of load has been on it when it failed? All these are important number 2 steps. So that when you get to number 3, that you're going to confirm that condition. Whether by watching the customer operator do, most likely, hopefully, you get your fanny in the seat and run it. And there are times, I know, I sat there with a machine that had 30 switches in it and controls for a drill rig. So yeah, you're going to watch, but you're going to be there one way or another and confirm the actual complaint and what it's doing. Sound, smell, sight, vibration, all of that. And then you're going to start thinking of what the problem is. And to do that, step number 1. You need to know that system so you can start listing the possible causes. Okay? And number 5, you're going to whittle down those causes. Actually connecting now. You're operating. You're adjusting. You're going through it again because you've listed your possible causes. It might be a big list. Might be a short list. Might be a no list. But you're going to go over here and do your adjustments and whatever and confirm the condition of the problem. Number 5. Number 6 is your repair. And number 7 is you're going to confirm that the repair actually worked. Because part of troubleshooting is you may have multiple systems involved and you don't know it until you've gone through all of these steps. You found something wrong that could cause your problem. You repaired it. Then you found another problem. And you go through the system again and repair the other system. I've run into that where there's been 3 or 4 problems. I had an excavator like that. It had a fuel system, an electrical, and a hydraulic problem. It didn't have just one. It had 4 hydraulic problems. All of those lined up. And I had to find them step by step when I went through them. And all I constantly heard from the jackasses at Anderson Equipment, why didn't anybody else find it? And I sat there and said, well, I don't know. My mind reader disappeared. The batteries ran out. The ex-wife burned the crystal balls. You want me to go through the list? I don't know. That's your problem. Mine is, I have a sticky spool valve here, a sticky valve there, possible sticky valve somewhere else. I have an electrical problem because it's not feeding the controller right on the engine, and a fuel system problem. That also means I have a bad injector someplace that doesn't show up until it runs for hours and gets heat sinked. Which one? I don't know. Why? Because we can't run it for 6 hours. We can't work it hard enough for 6 hours with 4 valves bad in the system, or 4 possible. And when we got done, we had a great working excavator, and then it started sputtering after it ran almost 8 solid. It did. It ran 8 solid hours before it started sputtering. And they said, well, what do you do? I said, it's got 7,000 hours. Needs a set of injectors and a pump. And they went nuts. Why didn't anybody else? Again, the same stupid question. I don't know, but they've put speed sensors in this until it's green. I'll put another one in too, and I think I did. It didn't fix it. Why didn't it? It fixed it before because every time you put a speed sensor in, the whole system cooled down. Everything worked fine. Fire it back up. They're running beautiful again, maybe for days. And they did this for 2 years. So when you go through your troubleshooting procedures, do not be afraid of these pumps or anything else in their systems having multiple problems. You found a bad pump maybe. Okay, great. The bad pump sends bad fuel to those injectors. Never replace just a pump unless you're under warranty or no one else wants to do it. Always request to replace the injectors and to clean out your injection lines in your fuel system and look for air leaks, etc. everywhere else. Change the transfer pump. That's insane. Well, that's why I say check with them to see where they want to go. Because the fuel pump probably failed either from hours and wear or bad fuel or bad transfer pump or air coming into the system or bad fuel tank or bad fuel cap. Why did the pump fail? You may have an injector that all of a sudden isn't opening the way it's supposed to, and the little VE pump can't develop the pressure continuously. It wore out for a reason. And if the injector is having a problem opening and the pressure is hyperpressurizing because the pinhole's stuck almost closed, now you've got an injector that's peeing and throwing smoke, just as if you have a bad pump. You should have checked that in the first place? Maybe. You should have heard an injector knock? Maybe. Maybe. But if all of the above adds up, always remember, a bad injector is bad for 2 reasons. Bad fuel and a bad pump coming apart. And maybe the pump hasn't failed yet. You have to look at all of these systems and find out what somebody wants to spend. Always remember that. One guy told me when I found a bad injector in a single-cylinder engine, oh, great, then it's going to work. And 2 of us just looked at him. Where did your brain go? Did it really fart? What do you mean? He said, what do you think caused the injector to go bad? Put a new injector in and have a bad pump. It was a horrible pump, not just bad. Duh. So go through your troubleshooting completely. If you're replacing a pump, you're either replacing injectors or testing injectors every time possible. They're going to balk at it. Too bad. Okay, that's it on your basic distributor systems, BOSCH VE VP44. So wait a minute, VP44 is electronic. It's electronic. The injectors aren't. It's an electronic version of the VE system. That's why I'm comparing it. Well, I've replaced both pumps. Not as often as others, but I have worked on both. I'm telling you, the similarities are there. Injectors are expensive. Maybe. They might be. And if there's any question, you If you have something to hold that injector body, it's usually 45 to 55 foot-pounds. Take that nut off of there. Some of them are lower, so know your torque. The older ones, almost all of them across the line were 50 foot-pounds. All of the old ones. Then the Bosch, you have to get your specs. Pull the tip off, look it over. If there's nothing leaking, put the new tip on and put her together. Test it. I can't test it without, yeah, they have to have a special fixture. But you can replace the nozzle. If you have to. It's better to buy the whole body. It's tested, ready to go. But I'm just saying, there are alternatives to what you can do. Tear it apart and find out which one has the stuck pintle. What's it going to do? Not work. You can use good fuel to put it back together, filter it, or spray WD-40 all the way down through there. That'll burn. Just giving you alternatives when you're on your repair. 45 minutes in. Did I give you enough to chew on for a while? I hope so. And always remember on those pumps that when you see the flange and you see a bolt head sticking out the side and it looks like it has a metal plate on it, it doesn't matter what brand it is. That's probably your pump shaft lock. And if you have one of them, and this is the last thing I'll leave you with because it does happen, somebody forgets to change that plate. They'll fire the thing up and run it, and after a while, all of a sudden the engine stalls and they can't restart it, and it's not smoking. They left that puppy in there, and the shaft spun. And it either tore the key off here, or it'll spin the shaft here and gall the things up and lock it up, snap the shaft off here. So you might even hear some rattling. Be careful. Now let's go backwards to your Delphi pump. What happens there? It's usually just seals and misalignment. And the Delphi pump, some people will pull the pump off and leave a shaft hanging there with two seals. If you don't replace those two seals, you're an imbecile. Never turn another wrench the rest of your life. This is on Delphi, Stanadyne, Roosa Master. Replace those two cup seals very carefully and grease them, and use a tool to put the back seal in that pump very carefully and make sure it's lubed well. Not heavy grease, but good grease. And sometimes assembly grease isn't enough. You want a nice thin film of grease so it'll slide up in that housing. But the problem now is that tab at the end of that shaft that's hanging there has to line up with a slot in here. Well, where's that slot at? And that slot has a dot. That shaft has a dot. They have to line up. It gets a little sketchy if you're not careful. But people do that so they don't have to take the shaft out, lose the key in the engine, or lose time on there. It keeps it timed there, but you have to reach in, turn it, line it up, get it all together, because if you turn those two dots 180 off, it's an offset tab. You'll seize your pump. Shafts have been known to snap because you'll notice up by the seals there's an area of a cutout. That's what that's designed for. Designed to break when something goes bad in the pump so it doesn't totally destroy it. Well, you've probably already wrecked it. And if you got that tab in there 180 off, it's enough pressure that you may have wrecked something. Just saying. Like the guy says, there's a fella on here that does some college, and I'm going to tell you how to look it up. And it's on the old Bosch pumps, or the old CAV, Stanadyne, Roosa Master pumps. Or not, well, it's not a CAV. Delphi, Stanadyne, Roosa Masters. Be the fuel. Put that in there, and he does a good explanation. And it'll give you an idea how all these distributor pumps operate in general. Later on, I'll cover Cummins cap system a little bit better. And what's the next one I wanted to cover? No, that pretty much covers two of them in one today. And I'll go through the P7100 Bosch. And the same thing, I haven't been into these pumps, but I've worked with a bunch of them. And the P7100 is famous across the world, and it has very little trouble to it. But I'll give you an idea how it operates. Denso, and yeah, Denso has a bunch of different pumps that mirror these. They have license. They have one that they build a distributor pump similar to the Bosch, and they build an inline injection pump similar to the Bosch P7100. And they're licensed, but they do their own thing, and they work similar. So when you're looking at these things that I'm talking about on this end, the Bosch and the Stanadyne and the Roosa Master and all of these, even the CAV Lucas going up through there, there's similarities in all the distributor pumps. And Nippon Denso has the rights to almost anything Bosch. common rail as well. And I'll talk about common rail later. But next I'll do the P7100 Bosch. Right now it's late enough in the day, and we're coming up on 50 minutes that maybe I should get my fanny out of here. I gotta get firewood. If you've stayed with me this long, more power to you. If you're if you stayed with this long and you don't know what you... Wake up! All right, I'm gone. Peace out.